So today we're going to talk about the law of sines, and basically, the law of sines is a way to find um, there's a relationship between the side lengths and the angles of a triangle. So if I have this triangle, capital A, capital B, capital C, when we label a triangle like this, and this is not a right triangle, this is just any triangle in general. The capital letters always refer to the angles or vertices of a triangle, and then across from that would be a lowercase letter that represents the corresponding side length. So this is angle A, and this is side lowercase a. Capital B is angle B, and then opposite of that is going to be lowercase b. And then angle C, opposite of C, will always be lowercase c. Now we have a tendency just to label triangles ABC because those are the first three letters in the alphabet. But there's a relationship on every triangle, and we call that the law of sines. And basically, I'm going to talk about the first application of the law of sines. Um, I can find the area of any triangle using what we call the law of sines. So it's going to be 1/2 times lowercase bc sine of capital A. And now, what's interesting about this is whatever angle you have, the law of sines is pretty easy to remember if you think of it like this. Whatever angle you have, you need the other two sides. So here I have angle A, and I'm going to need the sides B and C. Another variation or version of law of sines is 1/2 times, and we could pick any two letters. So maybe I'll pick AC. Well, that would be sine of what angle? Well, I have A and C. What I don't have is B, so that would be B. And then the third variation of this is the area of any triangle is equal to 1/2 times, we don't have AB. And then that would be sine of what angle? C. All right. So that's how we would use the law of sines to find the area of a triangle. So let's go ahead and just jump into example number 1. I have a triangle that looks like this. Okay. And this is B, A, C, and then they tell us that this is actually, this is example number 2. So we'll just do this out of order, I guess. This is example number 2, and we'll jump back to answer number 1, or example number 1. So this is example number 2. Anyways, and we're given that the measure of angle A is 135 degrees, and that this side length is 19 and this side length is 17. So now as I look at this, this is angle B. The side opposite of angle B is 17, so that's lowercase b. This is angle C. The side opposite of C is 19. So I'm asked to find the area of this bad boy. And so then the area of this is equal to 1/2 times. Now I have B and C, so I have lowercase b, lowercase c. What do I need to know the angle of? Sine of capital A. So now it's just plug and chug. My formula for the area of this triangle is equal to 1/2 times B, which is 17, times C, which is 19, times sine of A, which is 135 degrees. So let me go through here and do this real quick. So I'm going to say 0.5. Let's slide this up a little bit. 0.5 times 17 times 19 times sine of 135. And I get 114.2. So the area of this thing is approximately 114.2 square units, because it doesn't tell us if it's feet or inches or what it is. Okay?